It seems as one of the most ludicrously inefficient systems to move electrons around you could ever conceive.
Yeah. At least to move mass around
Yep.
that you could ever possibly conceive.
Yep, absolutely. So, Tyler, sorry to redo this to you, but let's re-give you an introduction for the sake of, you're not normally here on the Electronics Dev podcast.
Yeah, I'm not normally here trying to forecast out how many kilograms of electrons the internet moves on a daily basis, but I'd like to be a lot more because that's a fun topic. So.
It's a fun place to be. Maybe to give you just a little bit of an introduction.
Yep.
One of my good friends from YC, the Winter 24 batch that both Atopile and OmniAI went through together. And Omni does, well, it can read my data sheets. Which
Omni does PDFs. And so what we do is we build vision language models specifically for reading documents, reading images, reading PDFs in a really, really high fidelity manner.
Yep.
And yeah, one of the first things that we talked to Matt about was like, can we read a data sheet? Can we look at like a resistance curve and can we actually pull some numbers off of it?
Yeah. Imagine me begging saying that. Like that is
like, something along the lines of we've got these 10 million data sheets and we just need some way to turn it into a database.
Yeah, we have 10 million data sheets at something on the order of like 60 pages or 30 to 60 pages a sheet. You know, depends on the component quite a lot, but with embedded graphs, tables, all sorts of stuff. And so Omni has an incredibly unique approach to actually do the data extraction from a PDF. Do you want to just like super top level?
Yeah.
How do you get the data out?
Very, very top level on how do we get the data out? Well, I mean, we look at it. It's a it is a bit of a change up from like a lot of traditional OCR processes. So the whole idea here is just that a document is a visual format. It's meant for you as a person to print it out on a piece of paper and look at it with your eyes. And so what we do is we really take pretty much every page of the document, very like holistically run everything through a like single vision model as like a single page at a time, and we use that to actually translate it over into a more like human readable or machine readable format, which is typically going to be some combination of Markdown plus HTML to capture things like the table elements and graphs and flowcharts and all the other like weird elements there that go beyond just like natural characters on a page.
Yeah. So if I'm to summarize that another way, you literally take an image of the PDF, like a PNG for argument's sake, you huck that at an LLM, an AI model, a multimodal model, and then say, hey, what's on this page?
Yep. That is verbatim. And the fun thing too is like, that is seems like, very much like a hack of a solution here. And it works better than almost any other like OCR, like traditional model that people have been building and using for decades now. And you've got entire like industries built up around this, and none of them work quite as well as just like hucking the document to the LLM. And it's been a huge game changer too. Where like when we first started doing it too, like that kind of seemed like a bit of a silly idea. And then we just like start testing it, and they're like, oh, this is actually like 80% accurate. And then like the traditional OCR models are also about like 85% accurate. And then over the last year, it's just gotten like better, faster, cheaper, and to the point where now it's like we're like 96% accuracy on this model, and traditional OCR models are still like 85% character accuracy.
They're not really creeping that far.
They're not getting a whole lot of investment. And so it's just one of those things where suddenly it's won out both on the accuracy side and surprisingly the cost.
Really?
So I remember when we talked before, the 10 million, 60 pages each. So you're looking at like your 600 million pages of data sheets there. We were kind of like balking at that from like what would this actually cost to process?
Well, we're not paying like UPS scan prices of 25 cents a page. Like we couldn't afford that for 600 million of them.
No, for right now. And so it actually probably was around that. It was probably around, at that time we first talked about this, it was probably around 25 cents a page. Is what it would have cost. Now it's down to like 1 to 2 cents per page. Which is $10 per 1,000 pages. Like it's pretty much full on competitive with the traditional models, while also being better and being able to do things like interpret charts. Deal with like not unbounded charts. Charts without axes and like all sorts of like things that traditional models just couldn't handle. And that's in like the last like 6 months or so. Like we've had like a probably like 10x reduction in cost, just because you have like all these like open source vision models that are coming out, and then you have the quantized version of these models, and so you have the distilled versions as well. So it's like we've taken like a really beefy 400 billion parameter model, and we've just distilled it down to like the only thing we need is like the actual like image to markdown output from this, and this is down to like 32 billion parameters, which can run on like fully stacked MacBook. And so you're getting like more and more into like, wow, this is suddenly like really cheap. And another couple of years from now, like some of the
you can see where it's going.
I can see where I'm fully like willing to bet like 2 years from now, human level intelligence is going to run on an iPad.
I'll take that wager.
Yeah.
Yeah, I mean, not that I like strongly dispute it, but like, mate, that's a bet I'd love to. All right, that's a shake on camera. What's the bet for? You buy the coffees next time, or are we going higher than that?
We're going higher than that. Whoever's right on this one, and we'll have to come up with a definition on the
how dumb can the human be? Because we vary a lot.
They'll have to come up with a definition on intelligence, but I'd say whoever wins has to buy the other one, an iPad.
Oh, okay. Okay. Yeah. What definition of human level intelligence would you have? Let's do it.
Oh, this is one of those things where it's like LLMs today, like by far shatter like all of these like 1970s era like Turing test kind of things where it's like if a computer can do this, it is considered a human. And it's like we blew past all of that stuff like 4 years ago. And so now everyone keeps on like moving the goalposts. But I would say that one of the things is going to be the ability to like complete some sort of like open-ended task. So ability to like make a like multi-step process and actually follow the process.
Now, I don't imagine that you're betting on Siri here, because we both know that Siri's...
No. This is like I'm betting something else can run. I'm doing iPad compute.
I wouldn't constrain you like that. That'd be cheating.
It's the compute on an iPad. Because I think the compute on the iPad is going to go up. It's going to have like an M5 chip on an iPad at some point. It definitely
will. It's got the M4 already. So it's only 2 years away. If it didn't have the M5 by then, Apple's really goofed up.
And then size of models is going down.
But can I actually run it on my iPad, or you're just saying theoretically?
No. Yeah, I think you can actually run it on your iPad.
That's an important stipulation, because
does Olama have an iPad? Do they have an App Store app? They should. If not, they've got it's a great platform where you can just like pull down and run the open source models.
Okay, and human level intelligence, let's see. Ooh, what does that mean? Open-ended task, I like that. I can let it do something for a little while. I want it to... maybe something along the lines of like book a holiday. Like,
this is a... I hate that example. Not because I don't think it can do it.
Because you think you'll lose.
No, exactly. No, I hate that example because anything can book a holiday for you. Right now. This is like
it would just be a bad holiday.
Yeah, just be a bad holiday.
It's too hard. So, now we're onto the metrics. I know you guys have a big dash of metrics. Do you want to dive into that for a second, and like how you guys qualify your models and all of that?
Yeah, of course. No, we do tons of metrics. I'll say the two big things that we're like always tracking we have like our internal like how people use our product metrics, but then we have like our actual like benchmarking for accuracy metrics.
Yes.
And so we've got a couple aspects to it. So we've got step one, which is like OCR, and that is like we've got a page and we have got text. And we want to make sure that everything that was on the page is actually like in the text format in the correct way that we expect it to be. That's one of the big things that we've done like a big open source benchmark on. And so a lot of process that goes into that. And then the next step is we have got a page of text, like a clean page of text, and then we want to throw this to an LLM and extract some like structured JSON data. And that's like, we're looking at the fact sheet, we're looking at a resistor, and we want like, hey, I want to get like all of these tolerances back as like a JSON array. Like I want this something that I can actually like use within my product. And that's kind of like the real end of the day goal for most people. OCR is always like a midpoint. Where it's like we want to get something into like a machine readable format, so that way we can then put it into the JSON. Everybody wants just JSON at the end of the day. It's the main format. And so
the interchange of the internet.
The interchange of the internet. JavaScript object notation. Superior language.
Thank God. Thank God we made the binary for it, because God, you imagine the extra number of bits. How many kilos heavier would the internet be if we didn't? Okay, so you want to get into, and this, to annotate this out, for the resistor example specifically, this is so hard because they'll say, for each of these classes of tolerance, there'll be each of these things, except this type, because we don't make that one variant of this thing and that. There's like some logic baked into it.
Yeah.
And that's kind of the beauty of being able to use an LLM for this too, because you give it literally an image of the page and you say like, list out all of the possible variants of resistor that these guys make and their manufacturing codes or their ordering codes, for example, right?
And that is definitely like another hard part of it that we found a lot. So like the actual like OCR, like image in, just give me the text from the page. This is like a what you see is what you get type thing, where it's like literally you're just trying to make sure that like it's there, it's in the right format, nothing's missed out.
Nice, good benchmark, super clean results.
Super clean results, easy to measure. The next one, which is like, hey, I want this in the structured format, is so hard to do actually. This is like, it's very much dependent on your instructions. Like what format do you want it in? Was this document ever even like something meant to be in a structured format? Like that's the other part of it, where we had this a lot on our side where people were like trying to be like, hey, I want this, I want all this like structured information out. And we're like, okay, cool. Like, what are you looking for? They're like, well, over here I want this, but only when this happens, and not when it's like on this document. If this shows up on page 3, we don't really care about that one. We just care about the one on page 1. And it's like, you have all these, this is something we're still solving. Like you have all these just internal conditions or just like tribal rules for like what's important, what's not important. And it's hard for like customers to like go and like express this in a like just type it out. Like type out every rule that you have in your mind for like what makes a fact sheet, what makes data on a fact sheet important versus not important.
So we were playing with a similar approach based entirely off what you guys had learned of like, can we extract data from the data sheets? And this is before you guys really got into the graph side of things, which is also super interesting. We should definitely talk about. But we noticed that it was able to pick up on the errata without explicit instructions. So at the end of a data sheet, there was something saying, oh, correction number 3, we realize that this value is actually like a little bit higher, and you should reference that from here on out every time we say VCC max or whatever the actual attribute was. And it was to the point where we were like, hey, LLM, do these, whatever, 1,000 components. We compared it to the human data, took out, the 900 that were correct, and then we just examined the 100 that were quote unquote wrong. And in this one, we said, hey, LLM, this is wrong because we just looked at this one table. And in terms of tribal knowledge, it had gone all the way to the end of the document, recombined this, realized that we were wrong, and it argued back and was like, actually, no, here you go, have a look here. And you're like, oh, damn, like it's got more context than we do, at least.
We frequently do this like on our sites where we do like benchmarking like against like a ground truth data set. And so this is the one of the biggest learnings I've had on our side is that the ground truth data sets are like at most 90% accurate.
Really?
Like across the board.
90? Yeah. That's not high.
It's not high. No, that's a 10% error rate.
Is that in my taxes too? Like,
that's because we go through and we like look through like a lot of like data sets and stuff, because we'll have the same exact thing where like we see that and it's like LLM picks up on things where it's like it's reading the notes at the bottom as well as like what's on top. And so imagine like actually going through as like a person and reading this stuff. It's so hard to like do this, like go through, because you're scanning through, you're kind of like doing some like pattern matching. The one thing about the LLMs is like they're not lazy. Like they'll read the entire document every time.
If they want to consume more tokens by thinking, do you use the thinking models as well?
I do, yeah.
Okay, how do they benchmark compared to the?
Surprisingly, not as well.
Interesting. They're actively worse.
Yeah, so it depends on the. There's this whole other like kind of concept here, which is context. So you've got things where it's like, okay, like an invoice or whatever. It's like this is a single page, 2-page sort of document.
Simple document.
Yeah, very simple document, very obvious like what you're going to have on it. And then you also have like something else where it's like, okay, this is actually 120 pages. This is like a 10K like financial report or something like that. So
a microcontroller's data sheet.
Nice and complicated. Some giant like huge data sheet that has like a lot of information on it. Or like you might have something where it's like a like combo of data sheets. Like we've seen tons of stuff like that where it's like 500 pages and they're all stapled together. And it's just like has a ton of components inside of it. And so what we've tried to do as well is like some of this like long context recall, where it's also like the needle in the haystack problem that you're trying to benchmark against, which is like how well does it do at like finding something that's like on page 200 of a 500-page document. And what we found is that for the simple ones, for like the short, like kind of like obvious things, like this is an invoice, like give me the invoice date from here. The non-thinking models will actually outperform the thinking models
in terms of like what splitting cost, obviously, but
in terms of accuracy.
In terms of accuracy as well. Oh my God, that's crazy.
Well, it's so the way I frame it is like if I had like a little like invoice in front of me here, and it had like 5 things on it, including like the shipment date. I slide it over. I'm like, Matt, find me the shipment date from here. But wait. First, I want you to really think through this. And I want you to plan out your steps. Then you start looking at it, and it's like you start planning out your strategy for how you're going to find this data on the doc, and it's like way overkill. And so they just have a tendency, like anytime you're giving it like taking a single step process and making it into like a 10-step process, you're adding in
compounding error rate.
Compounding error rate. You're adding in different possibilities, and so we had things where it would just like, okay, like this must be a trick question. I have to give it a different answer. And so that's like what we found there. But then like on the 100-page documents, the thinking models do way better because it's actually, there's a reason that you would think about this. You would go through and do the steps. And so it's kind of a fun problem where it's like they'll overthink simple problems, but then they do really good on complex problems.
Yep, makes perfect sense. So do you switch models out, and for something like a microcontroller's data sheet, you would use a thinking model instead of the like sort of one shot like generic, or?
We've actually moved this on our side, but yes, we do. But we moved this on our side to be like a toggleable kind of thing. It's our agent mode, is what we do.
You didn't want to call it dev mode after the whole.
Actually, Figma sent us that cease and desist.
I did beg them for some advertising. I threatened to launch our own dev mode, and they didn't bite at that one. Unfortunately,
have your general counsel send them
a cease and desist.
Send them a cease and desist. But like actually, if you look back in the commit history, Atopile had we had this comment in here about dev mode.
We think you saw it.
We noticed one person at Figma start our repo, and we're assuming that's where you guys got the idea.
That's actually a big problem with patents. Have you heard about this? So there are some companies that patents, won't. Thank God. So there are some companies that actively dissuade their employees from like searching patents to the point where if you're on like a Discord server where someone links to it or whatever, open source projects, communities might have rules to say do not post patents links, because otherwise people who browse this, whatever, some Google employee for argument's sake, might see that link and come litigation time, therefore should have known about this technology according to their search history, and get in more trouble. Have you come across this?
Yeah, I actually have. And this
Personally?
So something that I learned here is that if you are going to develop like anything like hardware related, you are best served by literally never Googling it. Like because if you like establish that paper trail that like you found a patent here, then it just changes from like, if I went out and I like built something and then somebody later on thinks that like I'm infringing on their patent, then they have to like, come out to find me. The burden of proof is on them that you are willfully intruding on their patent. Now, even if like you are, you're building something that's like similar to their patent, they still have to prove that like you're building something that's their patented information, and so like kind of a fresh start there. But if you like Googled the patent, took a look at it on like Google, Google patent search, whatever, and then like kept on like building what you were building. Then they have this extra argument that it's like a willful, like
it's like 3 or 6 times worse, isn't it? If I remember correctly, like if they just generally in terms of the court will find something like 3 to 6 times the damages. Based on you knowing about it beforehand.
Because I think it goes like more historic. And
prehistoric.
Prehistoric. No, it goes like it can like look back or something like that. So like right now, if I build some trinket and then like later on somebody like finds it and says like, hey, this infringes on my patent. Then usually like I think what people typically do is like set up some sort of like go forward payment plan. It's like okay, like going forward, you're gonna get like some percentage of the sales from this thing until like your patent expires.
Now that we're aware of it, we'll pay you royalties.
Exactly. Now that we're aware. Whereas like if they are able to prove that you actually knew about the patent 2 years ago, they can try like to sue you, like claw back some of the revenue that you've got in the last 2 years. And so that's why the damages are just like way worse.
Makes sense. It's kind of fair as well, assuming your patent's granted in a reasonable fashion, not these Amazon shenanigans where they just sort of grab everything they can possibly think of. But if you come up with a new drug that cures cancer,
I've got such a like mix of opinions on patents in general. So it's like on one hand, somebody described it once to me as like patents are like the U.S. government's way of encouraging you to be open source.
Yep. Yeah.
Because like if you quote, if you patent something, it's out there in the public.
You got to put it out there.
Yeah, you've open sourced your design for this.
Yep.
And as a result, you now get the benefit of like 10 years of protection while you build it.
20 typically, right?
20. Wow.
Yeah, patents are 20 years if I remember correctly.
Insane. They should be 10.
They should be, yeah, definitely.
And yeah, but then of course the downside of like, there's no limit to like how many patents GE can file for every like possible variant of an LED. So that like it means that literally no other human could make like an LED without infringing on a patent.
Yeah, or even just like having enough fear that they don't bother, which is for GE's sake equally as good. They still get to, not GE specifically, but whoever does that they get to control the whole market.
Yeah.
So yeah, dangerous stuff. God, okay. Well, I wonder how that works with LLMs in the mix. If I have an LLM, if an LLM has read the patent and I ask it about something, I've now kind of ended up with that knowledge, haven't I?
Ooh, this is I haven't heard this suggestion before. This probably shouldn't go on camera. Like you're gonna start a whole new trend of patent trolls who are gonna be like, well, if GPT knows about this patent and we have reason to suspect that you use GPT in the creation of your device, then you infringed on our patent.
Oh, that's one that you want to duke out with a big company behind you, don't you?
Yeah.
It's like when Microsoft released or GitHub via GitHub Copilot to begin with. There was at the time I was working at Tesla still, and we were sort of looking at which of these solutions to use. And I remember reading some of these documents of like, GitHub will come to your defense in the case that you get sued for this specific copyright material that got Copilot got trained on under that set of circumstances, basically. Because otherwise, like, God, that's so you want to go up against whoever, Google for argument's sake, if you ended up with some of their code.
Somehow, Copilot regurgitates Google's code inside of your code base, and now they're going to sue you.
You really want to let the behemoths duke that one out before you get into the ring, with the leftovers.
Well, I think that's that's part of like the OpenAI, like, petitioning to have like LLMs excluded from copyright law. So it's like they can just, regurgitate, because like, all LLMs are trained on just like any bit of data they could possibly scrape from the internet. And so I think that by default, like they are just like, kind of ignoring copyright law. And it's like if you
couldn't practically have made them otherwise, right? Like I don't think so.
There's no way to actually make them in some sort of like copyright law respecting fashion. And then like you have this whole very like quasi thing where it's like, if if an LLM like regurgitates to you some advice on like a hardware project you're working on that it found inside of like a patent somewhere, in terms of like
they were open source, it probably doesn't know that it shouldn't give you this advice of like, hey, if you actually design your hinge in this fancy extra way, then it'll just probably work better.
It'll probably. I mean, I bet you like even like the as they're getting more and more into like the GPT like image generation stuff, I bet it could even like give you like a diagram at some point that it is like somehow like possibly lifted from like another design doc that it read at some point, and it's like billions of parameters.
The visual reasoning or the visual thinking behind or baked into LLMs is kind of incredible. We were discussing a little bit before as well about how you've worked out that you with this approach of doing not quite OCR but PDF deconstruction or PDF reading, you can actually read the graphs and charts and whatnot. And you are explaining how, based on reversing this process, and you started with generated data, you can deep fry it and then train an LLM based on the data that went in the first place and actually read these graphs more accurately.
Because if you're trying to, what you need for like training a model is just, data in, data out.
Yep.
Like this is what we're expecting to get in. This is what we expect you to produce out of this.
Yep.
And so one of the big things we do is like taking a graph or taking a chart and trying to just like turn it into a table format. Like our main opinion is like everything should be tables at the end of the day.
Not JSON.
Well, tables in the OCR step, and then later on in JSON.
Okay.
And so what we do is like, okay, we've got to pretty much come up with like a lot of good data on like what is what should we get out of this chart. And so the way you do it is just step one, generate tables of random numbers, random values, something that looks representative to what you're trying to chart out.
Yep.
Run it through like a charting library, generate just like 100,000 randomized charts of those numbers.
Yep.
Take some of those charts, run them through kind of the CRUD layer, which is just like scan lines, black and white.
This is adding CRUD, not
adding CRUD. This is the making it look terrible. Sort of like make it look like it went through like a Xerox machine 12 times, and then
and one from like the 1980s.
Yeah. Add those those lines, that line paper that has like the little like tear off like dotted things on the side, like add those on both sides of the chart there.
Yep.
And then you just flip it, and then you're like, okay, like
learn what went in.
Yeah, this is data in, data out. Like this crappy chart right here, we know corresponds to this underlying data,
Yep.
and so this is the training run you do.
And how much improvement have you seen based on that additional fine tuning? Is it fine tuning on top of these models, or have you tried to train a bespoke model for it?
It's fine tuning on top of the open source models.
Okay.
Training the bespoke model is also like largely impossible in terms of the actual amount of compute that goes into it. But you take the current state of the art like open source vision models, run it through the fine tuning data set. And good thing about like all these model architectures are like relatively similar, and so you're able to rerun these same like fine tuning runs on like newer models as they come out.
Okay.
And the improvements are pretty drastic. In terms of and we still like do like more and more like bespoke stuff too. Like when we like have some like particular like high volume use case of documents with something that's really difficult to read, we can also do more like generation of synthetic data that looks just like that one and use it to like hit those targets. But we've seen like across the board it go like 70% accuracy on the benchmarks on like the base case, up to like 92% accuracy after the fine tuning.
That's huge. Yeah. And I think the correct way to actually think about the accuracy ratings are not actually based on how much it's getting right, but how much it's getting wrong. Right. So you've gone from what you said 72. So what's that 28% incorrect up to what was the top?
Like 92, 93% there. So like 7% incorrect.
Yeah, right. Big, so it's a quarter of the incorrect results. Yeah, which is huge. You compound that out over a few steps, it's massive.
Oh yeah, no, I mean when you think about it in other ways, like think about a lot of traditional OCRs, so like always like this 85% rate. And it's like cool, that's 15% of the time it's wrong. And some of the other ones, like
what about people? You mentioned before, like 90% of any data set is.
That's people are pretty bad at some of these, just like pure like read the document and retype it kind of tasks. Because like as you can imagine, like you're reading something, you're just keying it in on the other side, like tons of inaccuracies there. And so I'd say it just largely depends on like how like specific some of these things are and like how like easy it is to key in certain values versus others. But I would say across the board, like we will frequently like do a comparison of like the model output to a ground truth data set. And like what we'll do is like we'll run this benchmark and we'll see that like, hey, it is the model is 60% accurate.
Yep.
And we're usually like, well, that doesn't line up with like doesn't sound right. It doesn't like line up with a lot of our expectations. And then we'll start digging into it, and it's just kind of like, wait, hold on. Like we'll go through and look at this like 1,000 item like manually annotated data set. And we're like, this is wrong. This is wrong. This is wrong. Like this is blank. This is not actually a document. This is like a picture of a dog. And so it's all data cleaning at the end of the day. Like that is such a hard problem for like anyone.
Yeah. I mean, reading, bring this back to electronics, reading data sheets in the first place is there's like merged columns and like all sorts of weird sub columns and annotations within the parameters, for example.
And errata at the back of the document saying like, by the way, this chart is wrong. Like,
like, come on, what are you talking about?
Why did you leave a comment saying the chart's wrong instead of just fixing the chart? But
it happens.
Yeah.
It happens. It's remarkable. And so like, you can't really blame us pesky humans for not wanting to read the whole damn thing super accurately. And there's definitely a one aspect to that, because I think if you really care about something, you're going to go double check it. You're going to really make sure I got this one value out of this table right. Like, yeah, sure, I believe you can do that 99% without it getting too cruddy. But like at an average of 90%, I believe that. It's a little bit better than OCR at 85%.
Yeah.
And then you're getting that up to 92 with a well-trained, fine-tuned model.
Yeah.
It's a grand improvement on where things were a year and a half ago.
No, it's amazing too. Like, the slight percentage increases.
Yep.
Yeah. I think as we've talked before, like they have like kind of dramatic, kind of exponential payoffs.
Yeah.
Because just, when it doesn't sound like as much to be like, all right, this went from like, 80% to like 90%, 92 to 93%.
Yeah.
Like, but I think we've talked before on like the compound error rates.
Yeah. Compound error rates. I love those charts.
Yeah.
But the way I read a book, it was computer science for, Algorithms to Live By, that one. It's a computer science book muddled in with a bunch of philosophy. It's great. Have you read it?
I've not read it, no.
Strongly recommend. One of my favorite books. And one of the examples, they basically go through chapter by chapter, some computer science principle that are all like statistical analysis of this thing is actually more efficient than coming to the 100% solution or optimal stopping problems. One of them was with the parking situation in San Francisco. And they're talking about how the council was like, okay, well, yeah, having a high parking occupancy rate is great because we're actually utilizing the resources we have. Having a 99%, awesome. But the way to actually think about that problem is if you're driving down a block and only 1% of the parking spots that you're looking for are empty, you're going to have a hard time finding parking, and that time matters to you.
Yeah.
If you go from 99 to 98%, really doesn't seem like a big difference in that direction. You're actually going from 1 to 2%. Doubling the number of free parking spots. It's the same with this error rate, right?
Yeah.
Because you're not actually going from 80 to 90%. You're halving the error rate, which is huge.
Yeah, exactly. You're cutting the error rate in half, which is like, that's the best way to think about it. There's a classic like MBA term for a lot of the like RPA work, and that's like the straight through processing rate.
Oh, interesting.
And that's it's a word you hear kind of a lot. Just the idea of automations in general, which is like the percentage of time that it was able to actually like go through a fully automated system without having to like flag something for someone to like come in and fix it manually.
Interesting.
And it's using a lot of like automation terms as well. Like how many times does somebody have to go in and like manually fix it versus like it was able to just run through the full process.
Yeah, interesting. Okay. And wow, okay. I'm glad someone's doing this, because next year when I need to enter something other than a W-2 into the tax system, please let me do this. In fact, if you guys just made a tax portal that would type it in for me, I would buy that tool in a heartbeat.
It's a good idea, actually. We should do that.
Chrome extension.
Chrome extension. We just upload your tax forms to it.
And just types it into the right field. It does this one AI agentic task really well, shows off your stuff, and it flags a thing at the end that says, and by the way, if you have any other documents that you or your company need to digitize, OmniAI has your back.
On sort of a separate subject, we talked about like some of the like cutting the error rates and stuff like that in half. One of the interesting things I've been looking at is like, what are the most effective AI agents out there right now? And I think that probably like one of the best ones is definitely like Cursor and Windsurf.
Yes, definitely.
In terms of like mass adoption, like clearly it is working.
Yes.
And do you use like Cursor or something?
100%. You'd be nuts not to.
Yeah. And so same here, use it all the time. And I think that there is one like really huge advantage that they have. Maybe two advantages.
Okay.
One.
Compared to what?
Compared to like everyone else trying to build like an AI agent in like a lot of like traditional like use cases, like building the AI agent to file your taxes for you or something like that, or building the AI agent to like automate your inventory spreading. Like the big advantage on the Cursor side is that you have immediately verifiable results because like you can write the code, insert the code, and did it compile, did it not compile, did it throw an error? And so you have this immediate feedback layer, which can tell you like whether or not it was right. And so it's one of those things where like normally like if you did like, AI to file your taxes for you or something like that. It's like, you'll learn if you were right or wrong 6 months from now when the IRS either audits or doesn't audit you.
Yeah, or in like 5 years. What's the limit on that? It's like 5 years they can audit your taxes back.
They can come back for ages and like get you later on.
You're screwed. Like what? I don't have receipts from 5. I didn't even live here 5 years ago.
Yeah.
Like, Jesus.
And so that like immediate feedback and some sort of like, checksums, like the results will have some sort of checksum for like, did this work? Did this not work?
Yep.
And then the second sort of big advantage there is not just like a human in the loop system. It's kind of like expert in the loop. If you're a developer and you want to be, call yourself an expert, but like typically you know what the code base is.
Yep.
And like you are like real time working alongside something, like always like updating, correcting it.
Yep.
And I think that's why it is like really like been, fully as like, able to penetrate what the market the way it has is because it's doing that. And, people keep trying to build like other agents. But the main thing about like Cursor and all the coding tools, like they're like fully supervised agents with like immediate real-time feedback. And that's just something that's really hard to get anywhere else in the world.
Yeah. It's not like you have a linter for your tax. Well, you might get linting out of a good tax filing system that says, hey, these things don't all sum up together, right? Which is like a convenient feedback mechanism you might have for taxes or like accounting documents. But for the most part, it's like, hey, how many... how much stock does this squibble on a Post-it note say we have of this specific item? Like,
there's no. Where's your feedback loop there?
Yeah, you, if I remember correctly, as well, ran the it's an anarchist hackerspace. I think they call themselves.
Ran a as far as you can say, you ran an anarchist space.
It's kind of a contradiction in itself.
A little bit of a contradiction there, but it's largely true. Yeah, that was a. Great space in San Francisco.
Right?
Noisebridge, yeah.
Very famous anarchist hacker space.
Very famous, yep.
So what does running that actually look like?
Oh, so here's how I like stumbled into this thing. So I learned a lot about like large nonprofits as well, and pretty much was in there just visiting one time because I got a bunch of tools. It's like this big like 5,000 square foot place in Mission, and pretty much a lot of people have just come together, loaded it full of a bunch of halfway working tools, and it's all free to use. It's all like donation based, and so just a lot of really cool people have been kind of propping it up with donations, and it's managed to stay alive in a incredibly high rent area for like 12 or 13 years now. So pretty impressive on a pure it's free donation based thing. And so I was just there one time just to use some tools. It was pretty awesome, and then I was someone was complaining there about like not having their taxes filed. The whole thing's going to get shut down or something like that. And then so I foolishly was like, oh, maybe I can help out with the taxes.
I'll do your taxes for you.
I'll do your taxes for you. I'm a finance guy. Like I can help you out with this. And
sounds like a Fondo email. Hey, can we do your taxes for you?
Yeah. And I'll tell you, if you want the fastest way to running a nonprofit, just walk in the door and volunteer to do the taxes for them one time. And it's just like, keys to the kingdom immediately. Because everyone, the prior person doing the taxes for the last like 3 or 4 years is just like, I'm out. Here you go.
Here you go. Thank you.
Here, I just added you to the bank account. See ya. And and then, you're stuck doing that for I was stuck doing that for like 3 years. And then you work your way into doing everything where you're like, oh, wow, like as I'm doing the taxes, I realized like we're not going to be able to make rent next month. It's like, we need to do a donation drive. And then, the next thing you know, you're just, you're full-time on
full-time on a not-for-profit.
Full-time on a not-for-profit,
on top of your job.
On top of your job, just...
Damn. And so what a donation drive there looks like? I imagine it's kind of quirky as well.
They're always quirky. It was like we were going to throw some like hackers theme like rave as like our donation drive, or like various like, costume things, or we do like hackathons and stuff. Oh, the San Francisco stupid shit that no one needs and other terrible ideas hackathon is something that they ran every year.
Okay.
And this is honestly one of the best hackathons ever. It's kind of like a more like hardware focused hackathon than anything else. And one of our like easiest ones to get a sponsorship for.
Nice.
But it was so much fun. And so
like, what are people building?
The whole idea was, you literally like you win if your idea is actually terrible and like no one needs it. And so what we, let's see, what are some of the best ones? So one of the best ones is somebody literally made a laptop that would set on fire if you had a seg fault. in your code.
Okay. Yep. Nice.
And so they'd like take the thing apart. They'd like taken like 1,000 like matches and like clipped it into the matches, like grind a little phosphorus off and like stuffed it in there, and then like put some little resistor in, and then written some code that like if there was a seg fault, it was going to trigger that and heat it up, and then the lab thing just like burst into flames. So that was a good one. Someone built an activity taser, and so it was to try and keep you moving, and so. You had little switches on the bottom of your feet. And so if your 2 feet were on the ground at any one point in time, you would get tased.
Okay, so it's not like if you hadn't got a Strava activity today. It's like right now, at all times.
It was like if your feet are ever not moving, you're getting tased. And so you're going to keep moving. And there's a whole bunch of great ones. It was it's a good time.
Mate, how'd you take the bins out? Like, how does this place even work?
Oh, right. I think I told you about taking the bins out.
I heard rumors about something funny going on with the bins, so I had to ask.
Yeah. So the one of the it's really like totally anarchist space. Like you just have to do like convince people to take the bins out, like take the trash out, like help clean up. And so we had tried to, whenever possible, don't count on people necessarily like wanting to go do the trash for you.
Yep.
And instead just try to engineer solutions as much as possible.
Yep.
And so the best way for taking the bins out is what you do is it was like Wednesdays or something like that at like 8:00. We had a big sound system all through the place, and it starts playing the Barney cleanup song, like clean up, clean up. And so to turn off the cleanup sound, the bins themselves have air tags on them.
Yep.
And the air tags have to be far enough away from the building, from the receiver there.
So it doesn't actually matter where, just away.
It should be away. They should be outside of the building.
Yep.
And so as long as you can get the bins outside of the building with the air tags far enough away, the sound will turn off. And otherwise, it just plays, and it's loud. It's like hard. It's in a locked server box, so it's like some people would try to like get up there and like turn it off, but at some point,
just take the bins
out. Take the bins out.
Yeah.
And so it's I developed this philosophy as part of like all the fun like hacks we did to like keep the place running and keep it clean and sanitary. And that is try to engineer things in such a way that the lazy solution is also the right solution.
Yep, I 100% agree with that. I always think of it in terms of slope. Like I imagine you're trying to climb a hill, and there's a cliff in front of you, but there's like a little slightly sloped goat track to the side. Like, which one are you going to take? And as long as you can keep taking those steps, well, lo and behold, at the end of the day, you're still going to be at the top of the hill.
Yeah.
And so you just need to make sure there's no inflection point somewhere where it's just a little too hard to overcome in the right direction.
Yeah.
Smooth that slope right out.
This is like stepping back. This is like a full like startup founder kind of mentality as well, which is like even for yourself, it's like you have to like make sure that because if you have like a million things to do every day, like you're always going to like at some point start leaning towards like the lazier solutions, and so like try to like as much as possible build the automations. So that way it's just like even if even if you tend towards like the absolute bare minimum, you're still at least doing something right.
Yep, that absolutely makes sense. Man, it's crazy.
Now, what about designing circuit boards?
Yeah, designing circuit boards. Well, you do end up with the right tools with an immediate feedback loop, right? Because you can build linters for your code. So designing circuit boards with code, I should be very clear that you can build a linter to do the exact same thing. We actually use Cursor for our electronics design now because it's all just code, and you go through, and then you get, I demoed it just yesterday, you get compiler errors if you, for example, have two devices on the same I2C bus that have conflicting addresses. If that, you've built some electronics projects over the years?
I have held a soldering iron.
Wow. Oh, there we go. Some Arduino-like stuff?
Yes, some Arduino-like stuff. And there's some Raspberry Pi stuff. I've done some, built a bartending robot.
Oh, yeah?
Yeah.
Hell yeah.
So,
what were the dispensers with what are the peristaltic pumps? Or
yes. Oh, man. We went so deep on the peristaltic pumps. So first of all, peristaltic pumps are awesome. Really expensive.
Really?
Yeah. They're like $60
no,
for like a little,
They're not, because we bought a bunch. We bought cheaper ones than you did.
Well, I don't know. Maybe we were sourcing them from the wrong place, because we're also trying to like use them because they're like food grade more so because it's like ideally like you can actually use this. And so the reason we had the issue is like some of their most common use cases are like in surgical applications, and so like the price gets driven up quite a bit. No, actually, like right downstairs from here is a DNA Lounge.
Okay.
And it's like some super old timey, like, SF, like bar and club. And they do once a year a robotic bartender competition.
Oh, that's so fun. I got to get, when is it? Do you know,
I
roughly?
had no idea because the internet probably does.
Yeah.
But we built like a full size, like vending machine size, like robotic bartender.
Yep.
And we were doing it. It's an all pumps based, and so we had this like big switchboard on the back of it. And
Hell yeah.
We had like one set of like peristaltic pumps, and so we ended up just using the peristaltic pumps for the soda. And then for the rest of them, we used like air compressors. And so what we learned there with is like, we take so you take like the vodka bottle or something like that.
Yep.
We like 3D printed these molds, so we could do like some silicone molding to like put these stoppers in.
Yep.
Like one would be like an air intake, one would be like the one that goes all the way bottom, so you pump air in, vodka comes out.
And then you've just got a pneumatic solenoid on each of them.
Yep.
Okay. And
we
then
just have a big board of like solenoids there, and like we have like 25 of them. We've got like our like array of like peristaltic pumps there.
nice. And so it really aggressively shoots out the liqueur, or
No, it's actually pretty
nice and gentle.
Because these the little like air pumps and stuff that we had were like
okay.
pretty weak, and those are like,
you said air compressor. I was thinking you were dumping a tank in there.
no, we got these little tiny air compressors, and they're like super weak, but they're like $4 each or something like that. So like every bottle had its own little like mini air compressor, and so we had a breadboard, like a big switchboard, and a bunch of like 5x5 timers that we used for a
custom
lot of
board
it.
for that one.
No, like a breadboard.
Okay, breadboard.
Which could have been a custom PCB at some point.
These days. How long ago was that now?
Like 5 years ago or something like that.
That was the cusp of when like JLC and PCBWay and PCB GoGo back then were all becoming like useful and prevalent. So too early to do. But these days it's amazing how much like custom stuff you do, just like snap of the fingers.
Mm-hmm. And would have been, probably would have been better too. We had what's the, it looks like a little 3D printer, and it etches out circuit boards.
Oh,
what's that thing called?
Like the machines, the circuit boards,
machines,
cut the
circuit
traces.
boards. Yeah.
Oh, there's a few of them, but yeah, okay.
Little like white box one or something like that. I remember it was like very expensive at the time. It was like a $5,000 little like thing.
They still roughly
little
are.
Like PCB mill.
Yeah.
But
milling PCBs has never been as good as you'd love it to be, because you can only really do one side with the alignment you can realistically get on a home setup like that. And then like one-sided traces are like pretty rough to actually connect everything up properly, which is one of the bigger problems. But you've obviously seen the lab upstairs where you can do, there's a lot you can do with high power fiber lasers, which again, like last 5 years have actually become price accessible. And you can do some really cool stuff with them too, and actually cut custom boards at home. In theory, you were making fun of me before about it, but in theory, you could get to the end of that process. But back on the error rate of PCB design using code, which is super, super exciting. It seems like anytime you get a feedback loop like this is why software tools are so good, right? Is because software developers want the better software tools, and so they build their better tools for themselves, and they're their own user, which is the best like talk to your user loop you could possibly have. You just build the thing that you want in front of you, and it's great. And then that's why mechanical or machinists have just the best vice, or like whatever, the best fixturing, the best tooling, like physical tooling to run a mill, all of that kind of stuff. Because they can build it themselves. And it's the same reason CNC machine software currently sucks, because like they're not software engineers. And so what I'm excited about here is by closing this loop with being able to design electronics with AI means that you're kind of putting AI in the loop of designing itself in a bigger way. Which obviously they're already using AI to design and optimize the chips for inference. And then, you can do that now with some more of the hardware stack, the PCBA. They're good at writing their own software. And so you get to tighten that loop one step further beyond what you were able to do, and let the AI regenerate itself in hopefully the least scary way possible.
This is AI is able to generate the hardware that it itself will run on. That's absolutely. It's like some of the prompting techniques where it's like, yeah, you will be fired if this code doesn't work, or like I will tip you $100. Like I feel like for the PCB side of things, be like, you are a helpful AI agent. You are writing chips that will go into running yourself.
They'll be running your children.
Yeah.
Oh my god! I really better do a good job of designing this piece.
You're building the next gen of GPUs that are going to be running their child processes.
Yeah. Look, Tyler, thank you so much for coming in today. It was great chatting to you, mate. And well, look, I hope to catch up with you soon.
Yeah, likewise. Appreciate the time today. Love getting to take a break from some of the PDF stuff, talk hardware, start measuring how many electrons are on the internet.
Perfect. I'll catch you soon, mate. Have a good one.
All right. Catch you later.